All right, moving on into the graphing section of the review. Keep in mind you will not be able to use a graphing calculator on this section, and I think that kind of makes sense. So anyway, graphing these, I think I put 6 of them on the review. So starting with 2 sine 4x plus 1, the second I see that I'm doing a sine graph, I automatically think, okay, I know sine starts at the origin and completes its first period like this. And I do want you to label the x-coordinates of the max and the min, as well as the x-coordinates of any x-intercepts. So I want you to label those points. And with my sine and cosine graphs, you want to start with period and amplitude. Amplitude is easy. That's just the number in front of your sine or cosine. And remember, amplitude is always measured with a positive number. If this were a -2 sine x or -2 sine stuff, amplitude would still be 2. So my amplitude is 2. My period is 2 pi divided by the coefficient of x. And in this case, that's 4. So 2 pi divided by 4, and that reduces to pi over 2. And then the plus 1 means we're going to shift up 1. And when I have a vertical shift for sine or cosine, I actually like to do that first. So let me get my axes going. I'm going to put my x-axis right here. And I'm actually going to start with shifting up 1. Let's see, I want that to be black. I'm going to start shifting up 1, and I will put a little dotted line, and this is going to serve as my x-axis. I'm going to center my graph around that line at y equals 1. And then I'm going to start with the rest of it. We'll see my amplitude is 2. Since it is a sine graph, I know I'll start in the middle, start right here, and then I will go up, and my amplitude is 2, so I'm going to start at 1, I'm going to go up to 3, and then I will go down to -1. Let's see, I like to section off my x-axis, in this case my midline at 1, so 1, 2, 3, 4, and that's where I'm going to finish. I will go up to my amplitude of 2, which takes me to 3. Then I'll hit my x-axis, and then I'll come down and bottom out at -1, and then I'll come back and hit my x-axis. And this is what one period of this sine graph looks like. And remember, your sine and cosine is a wavy graph. It's not supposed to be pointy. So there's my graph. And the last thing I need to do is label my x-axis, or in this case, label this midline to reflect my period of pi over 2. So if my period is pi over 2, I'm going to start and finish. This is pi over 2. And then I need to figure out how much each little interval is. And I've divided this first period into 4 sections. So I'm going to do pi over 2 divided by 4, which is the same as pi over 2 times 1/4, which is pi over 8. And so that pi over 8 tells me that each little interval is 1 pi over 8. The next one would be 2 pi over 8. The next one would be 3 pi over 8. And this one is 4 pi over 8. And if you look at 4 over 8, that does reduce to pi over 2. And I'm okay. If you don't want to reduce them, you don't have to. But 2 pi over 8 does reduce to pi over 4. So you could label that pi over 4 if you want to. You can leave it as 2 pi over 8. That will not hurt my feelings. I've already taken care of the shift up 1. That's why I use this dotted line as the center of my graph. Amplitude is 2, period. I've got everything taken care of. So there is our graph of 2 sine 4x plus 1. Let's see, what about this one? -1/2 x cosine. Okay, this is a cosine graph. So I'm thinking cosine, I know, starts up high at the amplitude, and it finishes its first period by coming down, and it completes its first full cycle right there. And just like the sine graph, I want you to label x-coordinates of any x-intercepts and any max or min value. So you need to label all of these x-coordinates. And let's see, now we've got to find amplitude and period and anything else. Amplitude is 1/2. Remember, you do the absolute value of that. So my amplitude is 1/2. I'm going to go up to 1/2 and down to -1/2. But the negative, what that negative actually means is that this graph right here, is that just one big thing? Nope. Let's see, this graph right here, since my function is negative, I'm going to flip the graph upside down. So my cosine graph now, instead of starting up high, since it's a negative cosine, it's going to be starting down low because it's a negative cosine. The period is 2 pi divided by the coefficient of x. And my coefficient of x here, there's not one written, but it's a 1, so 2 pi divided by 1. My period is just 2 pi. And then the plus pi over 2 is a shift left pi over 2. Now, horizontal shifts, if I go left or right, I do wait and do those at the end. If I go up or down, I will go ahead and do the up or down first, like I did with this sine graph. But with the left or right graph shift, I'm going to do that at the end. So let's get my axes going. Let's get my axes. Let's see, cosine starts down low. This one's going to start down low, and my amplitude is 1/2. So I'm going to start at negative 1/2, and I'm going to go up to positive 1/2. Let's see, I'll section this off. 1, 2, 3, 4. I'll start down here. Come up. I'm going to hit a max right here. Come back down. And what I'm about to graph right here, I'm going to do this dotted. What I'm graphing right here is my graph of cosine, except I did not factor in the shift left pi over 2. That shift left has not been taken into account. I swear I just turned that red. Did I not? Let's do, there, okay. So I have not shifted yet. I'm going to wait and do that at the end. I am going to go ahead and label my x-axis because it's going to help me out with my shifting. Let's see, my period is 2 pi, so I'm going to finish right there. And then to figure out how much each interval goes up by, I'll do 2 pi divided by 4, which reduces to pi over 2. So this is going to be 1 pi over 2. This is going to be 2 pi over 2, which is just pi. This is 3 pi over 2. And this is 4 pi over 2, which is 2 pi. And what I have right here in green, this is the graph of y equals negative 1/2 cosine of x. I have not factored in the plus pi over 2. So now I need to take each one of these points and shift to the left pi over 2. And there's a couple of different mechanisms or ways that you can do that. One of the ways I showed you is to list all of your x coordinates, which I have this point right here, that's an x coordinate of 0. This coordinate right here is an x coordinate of pi over 2. And then I have an x coordinate at 2 pi over 2. An x coordinate of 3 pi over 2. And an x coordinate of 2 pi. And if you shift left, that's 2 pi over 1. If you shift left pi over 2, then what you do is you subtract pi over 2 from those x coordinates. So I'm going to subtract pi over 2 from each one of them, minus pi over 2, minus pi over 2, minus pi over 2, minus pi over 2. And my new x coordinate, whatever I get, is going to be where I need to move. So 0 minus pi over 2 is negative pi over 2. So that means this point that did have an x coordinate of 0 needs to move to the left to negative pi over 2. So this point right here is going to move over to the left right there. Pi over 2 minus pi over 2 is 0. So this point that was at an x coordinate of pi over 2 is going to move over to 0. And the shift on this one is actually very nice because I'm shifting left pi over 2, and that is how long each of these little sections is. So if I go left pi over 2, I'm simply going to go left to the previous marked x coordinate. So 2 pi over 2 minus 1 pi over 2 is 1 pi over 2. So this point's going to move over here. 3 pi over 2 minus pi over 2 is 2 pi over 2, or just pi. So the point at 3 pi over 2 right here is going to move here. And my last one is going to move to 3 pi over 2. And so now I've done that shift. Now I will connect those points. And this is that blue graph is the graph of negative 1/2 cosine x plus pi over 2. There we go. So there's how I would graph that one. Vertical or horizontal shifts really are a pain in the rear end for trig graphs. And there are a couple of different ways to do it. One way is to subtract whatever you're shifting or add if you're moving to the right. Another way is to simply look at the interval and hopefully it's a nice sexy shift. All right, let's see. Let's move on. 3 secant of x over 2. All right, now if you remember secant, kind of going into my thought land here, if you were going to graph secant, I remember that secant of anything is 1 over cosine, right? Right, y'all remember that? So when I graph secant, I actually start by graphing y equals 3 cosine of x over 2. And I'll let this graph of 3 cosine x over 2 be my base graph in order to generate the secant graph. So cosine, I know, starts up here at the amplitude and finishes a period like that. My amplitude is 3. My period is 2 pi divided by the coefficient of x. In this case, the coefficient of x is 1 over 2. It's a 1/2 x. And 2 pi over 1/2 is the same as 4 pi. So there's my period. And I'm going to start by graphing that cosine graph. Let's see, so my amplitude is 3, so I'm going to start up at 3, and I'm going to kind of cheat. And it's not really cheating, but I'm just going to put a mark and call that 3. I'm also going to go down to -3. I will section off my x-axis, 1, 2, 3, 4, and then I'm going to graph my cosine based on that amplitude, and I'm going to go through those 4 points. And now when I graph my cosine, I am not going to make it really solid because, remember, we're actually trying to graph secant. This cosine graph is actually just a middle something to kind of aid me in getting the secant graph. So there's my graph of cosine. And for the sake of having a more accurate graph, I'm actually going to carry it to the left also. I'm going to do 2 periods right here. So my cosine graph, it'll also go to the left. It'll hit those points. It's my x-axis right there, bottoms out right there. And I do need to label my x-axis also. My period was 4 pi. And this one's going to be nice and sexy. 4 pi divided by 4 is 1 pi, which means each little interval is marked off by 1 pi. So that's 1 pi. This is 2 pi. This is 3 pi. Now remember, that's the cosine graph. We need to graph the secant graph. And the trick to graphing secant is you put vertical asymptotes everywhere cosine hits the x-axis. Everywhere cosine hits the x-axis is a vertical asymptote for your secant graph. So let me get my vertical asymptotes going. I'll make them blue, I guess. Sure, what the heck. So I'll draw a vertical asymptote. That was weird. Vertical asymptote. Vertical asymptote. Vertical asymptote. And then we will graph the humps of that graph, of those asymptotes, man, I can't talk. The secant is the humps of cosine. Just remember to follow the asymptotes. So we come up, follow the asymptotes, we hit that hump, and then we come back down. We come down, follow the asymptotes, hit the hump, go back up. Follow cosine, or follow the asymptotes, hit the hump of cosine. And there's going to be another one right there, and there would be another one over here also. Yeah. Now the blue graph is the graph of secant. The blue graph is the graph of y equals 3 secant of x over 2. The red graph was the cosine graph, and that was just there to kind of aid me in getting that secant graph. So there is a secant graph. Good. 3 more, and I knew these were going to be the long ones. All right, so we have negative cosecant. All right, cosecant, remember, is 1 over sine. So if I'm going to graph negative cosecant of something, I'm actually going to start by sketching the graph of negative sine, 2/3 x, minus 3, which means I need to find period and amplitude. The amplitude is going to be 1, but since this is a negative sign would start at the origin, but instead of going up, negative sign is going to do this. So that's kind of what my graph of negative sine will look like. Period is going to be 2 pi divided by the coefficient of x, which is 2/3. And, ooh, this one's going to be tricky. 2 pi divided by 2/3, that's 2 pi times 3/2, which ends up being just 3 pi. So we have a period of 3 pi, which is going to be kind of interesting when it comes to labeling your x-axis. And then we also will start by going down. Actually, I'm graphing the sine one. We're going to start by going down 3. So let's get my axes going and get my graph of sine going. If I'm going to shift down 3, then I need to make sure I leave a lot of room for me to go down 3. And my amplitude is only 1. So I'm going to put my x-axis kind of high. I'm going to go down 3, so down 2, 3. And that's where my midline is going to be. So let's start by putting my midline at 3. There we go. That's where I'm going to start my graph. Sine starts at the origin, which now my origin is down here because I shifted down. And my amplitude is 1, so this thing is going to go down to -4 and up to -2. We go up and down 1 unit for the amplitude. And this is a negative sign, so we're going to start by going down instead of up. So let's section off our x-axis. 1, 2, 3, 4. We'll start by going down. Come up, hit the x-axis, or hit my midline. Go up, come back and hit my midline, and I know the period is 3 pi. Now here's where you're going to get angry if you aren't angry already. I need to know how much each interval is. I'll do 3 pi divided by 4, and unfortunately that doesn't reduce. So this x-coordinate right here is going to be 3 pi over 4, and that's how much we have to add to get to my next one. So the ones we've done so far, it's just simple. It was like 1 pi over 8, 2 pi over 8, 3 pi over 8. Well, now each jump represents 3 pi over 4. So this is 3 pi over 4. My next one is going to be 3 more. So 3 pi, another 3 pi over 4 would be 6 pi over 4. Another 3 pi, 6 plus 3 is 9 pi over 4. And if I go 3 more, this would be 12 pi over 4. And 12 over 4 does equal 3 pi. So that all checks out okay. So let's sketch my sine graph. It's going to look something like that. And for the sake of time, I'm not going to do another period. I do know that my cosecant, because remember we're trying to get cosecant, my cosecant will have vertical asymptotes everywhere this thing hits the midline. So let's get my vertical asymptotes going. I'll do those in blue. So I'll have a vertical asymptote right here. I'll have a vertical asymptote right here. I'll have a vertical asymptote right here. And then we will graph the humps of sine. So let's get ready to graph the humps of sine. I'm going to follow the asymptote, come up, hit the hump of sine, go back down. Follow the asymptote, hit the hump of sine. In this case, I'm going to go back up. And so that blue graph is the graph of negative cosecant of 2/3 x minus 3. Good, good? Good, good? Good, good. Questions, comments, concerns, thoughts on life? I think there are 2 more. These graphing ones take a while. I knew this video was going to take a while. This one's 18 minutes already, and I still have 2 more. Okay, so we have cotangent, and then I think the next one is a tangent graph. Yeah, tangent of 2x. All right, so 2 cotangent of x minus pi over 2. Now, when I'm doing cotangent, in my mind, I'm thinking, all right, let's see, cotangent of something is the same as cosine over sine. And you do need to know that cosine over sine is your cotangent, and the one on bottom is the one I'm concerned with. That's the one that's going to give me vertical asymptotes. The denominator gives you the vertical asymptotes, and it's the same thought process I used for cosecant and secant. I thought of secant as 1 over cosine, and whatever's in the denominator gives you your vertical asymptotes. So I started by graphing cosine in this case. Cosecant is 1 over sine, so I thought about sine and where it hits my x-axis or midline or vertical asymptotes. Sine again is in the denominator for this one, so I'm actually going to start by graphing y is equal to 2 times the sine of x minus pi over 2. And then I will use this graph to generate my cotangent graph. So let's see, my amplitude of this sine graph, I'm going to do this in red. My amplitude is 2, and my period is going to be 2 pi divided by 1, which is just 2 pi. And I do have that pesky shift right. Left and right shifts with trig graphs are really a pain in the butt. So I'm actually going to start by graphing just the amplitude and the period first, and then I'll tackle the shift after all that. So let's get our axes going. Y-axis, x-axis. I know that my graph of sine starts at the origin, and it will go up to whatever the amplitude is. My amplitude is 2, so we'll go up to 2 and down to negative 2. I'll section off my x-axis, 1, 2, 3, 4, and my sine graph will go up, then it will hit my x-axis, then it will come down, then it will hit my x-axis. There we go. And my period for my sine graph is 2 pi. And if you do 2 pi divided by 4, you get pi over 2, which tells you how much to count by for each interval. So 1 pi over 2. If I go another pi over 2, this is 2 pi over 2. This one's 3 pi over 2. And that's 4 pi over 2, which is 2 pi. Then I now need to shift to the right pi over 2. So I'm going to take each of these x-coordinates, and if I shift right pi over 2, this is going to be a nice one, because my intervals, my x-axis is labeled in intervals of pi over 2. So each point is simply going to shift to the right one interval, pi over 2. This point is going to shift to the right 2 pi over 2. This point is going to shift to the right pi over 2. That'll put me at 3 pi over 2. Shift to the right. And this one's going to shift to the right as well. And I do need to find that x-coordinate, so I'll do 2 pi, and I shift it to the right, pi over 2. Let's see, 2 over 1 is the same as 4 over 2. That would be 4 plus pi is 5 pi, or 4 pi plus pi. And my 2 stays the same on the bottom. So this is an x-coordinate of 5 pi over 2. And I will shift my graph to the right with it. Now I'm going to kind of cheat, because I can do this. My graph will shift to the right, pi over 2. Are we good? Are we good? Maybe I'll make that blue. Say make it blue. There we go. All right, so there is my new graph. I've shifted it to the right, pi over 2. Now to go back to the cotangent graph. We just graphed sine. Now we've got to get cotangent. And just like the secant and cosecant graphs, anywhere that sine hits my x-axis, that is going to be a vertical asymptote. So I'm going to drop vertical asymptotes at all of those coordinates where sine hits the x-axis. So let's drop vertical asymptote, vertical asymptote, vertical asymptote. Come on. There we go. And what you need to remember for cotangent, you don't graph the humps. This is not a cosecant graph. That's what you do for cosecant. Cotangent has this general shape. You have vertical asymptotes, and between the vertical asymptotes, you hit right in the middle of the x-axis, and you come down like that. That is your general shape of cotangent. And so that's what I'm going to do between my vertical asymptotes here. I'm going to come down. I'm going to hit my x-axis right in the middle of the vertical asymptotes. We're going to come down. We do a little snaky S thing. We come down, do a little snaky S thing, and keep going down. So that is what our graph of cotangent would look like. That green graph is the graph of cotangent. Oh, goodness. All right, one more. One more of these. These are the tough ones. Tangent of 2x. Okay, I'm going to tackle tangent the same way I tackled cotangent, except we need to be aware that tangent of anything is sine over cosine. Now this time, cosine is in the denominator. So cosine is what I'm going to start with to get my graph of tangent 2x. So I'm going to graph cosine of 2x, and this is not a too difficult one. Amplitude is 1, my period is 2 pi divided by the coefficient of x, which is 2. 2 pi over 2 is just pi. There is no shift, which makes this nice. So I will go ahead and get my axes going. Go ahead and get my axes going. Cosine starts up at the amplitude, so I'm going to go up to 1. I'm going to go down to negative 1. Cosine will start up here, and then I'm going to finish one cycle at an x-coordinate of pi because that was the period. So I'm going to come down, hit here, come up, hit my x-axis, and finish up high. So this is my cosine graph, finishing at pi. Let's continue labeling my x-axis. If I divide pi by 4, that doesn't reduce. So each of my x-coordinates is going to be an interval of 1 pi over 4. This will be 2 pi over 4. This will be 3 pi over 4. And that's just pi. And then tangent, we will have vertical asymptotes everywhere cosine hits the x-axis. So now I'm going to go tackle the tangent graph. So I'm going to drop vertical asymptotes everywhere cosine hits the x-axis. So let's come down. I kind of missed that one. I'll move it over in a second. Drop my vertical asymptotes in. And then the shape of cosine, it's very similar the shape of tangent, it's very similar to cotangent, except tangent, between the vertical asymptotes, you still hit the middle, but you start down low and you come up. It resembles x cubed. Not exactly, but it resembles x cubed. So my tangent graph, I will hit right between my vertical asymptotes. So I'm going to come up, and my tangent graph is going to look like this. Good. So that blue graph is the graph of tangent. The red graph is just there to help me get my tangent graph. I think that's finally all of it for the graphing. The graphing is a pain, but there it is.